So, what are the problems? So, using embryonic stem cells, and if somebody of you is very religious, you may have your own concerns, and it's up to you. The other thing with embryonic stem cells, because they have such a strong potential to become any tissue, they can do whatever, and we have no way of controlling them. And one of the things that they do, the whatever, that has been already reported in the literature is cancer. So stem cells, they are very nice, but you need to know what you do, how you do, and how to control them, okay? So there is nothing that is going to be very simple. The other issue that has been reported, and particularly in animal models of disease, is the fact that they don't live for very long. So you inject those stem cells and they disappear. They have a very important biological effect. You can get tissue regeneration, but the cells that you injected are not there. So what they have done, apparently, is to induce an endogenous process in your own bodies that starts regenerating. So those cells are capable of producing factors, and this is the most important thing for us to understand, which we don't know enough, that are capable of switching on some biological process in the body of the individual that can repair the tissue that has been. And as I mentioned to you before, while embryo cells at the beginning, while they are not differentiated to anything, they are non-immunogenic. Once they become a neuron or once they become something else, they will be immunogenic and your immune system will see them. You can use adult stem cells, but if you are old, they are not good enough for you. There is, however, a way that investigators are doing these days, that is to try to reverse those adult stem cells to an embryonic stage. And that can be done, but the process to do it is extremely complicated and is based on the fact that you have to put in those cells genes that are normally expressed in cancer cells. Now, the expression of those cancer genes has to be there just for a little while, but then after that, the cells will become normal. The problem is if you put the genes there, you need to be able to remove them. We are not there yet. And all the other issues of immunogenicity, short lifespan, and so on is still to be seen. The thing that I haven't commented on was cell fusion, and there are many, many reports in the literature in which what has happened is not that the cell that you inject really regenerates the new tissue, but that cell fuses with the cell that is in the tissue, and that cell becomes having two nuclei. So you have two nuclei in the same cell, and the cell that you injected just becomes part of the cell that was there. And that can be a problem because if you have too many chromosomes in a cell, you can cause cancer. Now, what I would like to know is how can we manipulate the endogenous stem cells? Because we know that they exist. And the question is, can we find the factors that are necessary to regulate those endogenous stem cells so that we can repair ourselves without the need of injecting something from the outside? So this type of slice of brains you have seen before. The blue arrows show you the myelinating plaques, and the red arrows show you some plaques that are trying to remyelinate, but they are not successful. So what it means is there is something that is stopping the oligodendrocytes to myelinate plaques in MS, and we don't know what is stopping them to do it.